Hello, assalamualaikum guys. So we are back online. Okay. So tak apalah, dah jelaskan whatever it is. Okay, so last week Dr. Siti have covered on the discrete random variable. So we'll continue on the continuous random variable. Okay, a continuous random variable can only take values over an interval. So for example, kalau you have a lifespan of a certain species of insect, okay, so katalah it will be something like 2 months until probably 36 months. Okay kan, so there's an interval over there. Okay, so there's a maximum and minimum values that you can take up for a continuous random variable. Okay, and the weights of newborn babies in the country kan, height and then distance of students home from school and so forth lah. So usually continuous random variable will be associated with measurements of characteristics such as time, mass or length. Okay, so now, can continuous random variable be discrete? Okay, so basically, it depends on your measuring instrument. Okay, so for instance, if you are, looking or measuring heights. Okay, so if your tool that you use to measure the height, scale here, it's like, there's no point something, kan? So it's just like 150, 151, 152. So it can be a discrete random variable. Have a little bit of discussion. Sebenarnya bukan discussion pun. I tak boleh tanya you all pun. So I jawab seorang-seorang. Okay, so you like to study the ecology of a lake. Now define the possible random variable x and also find the possible maximum and minimum values that you should consider for the random variable x. Okay. So one possible random variable x may be the depth of the lake, or maybe a temperature, or maybe how long is the fish in the lake, or how many ducks in the lake, or the area of the lake, and there's so many endless. Okay, the maximum and minimum values that you should consider for random variable x. For instance, if you take the depth measurement, your maximum minimum values should take, like, depth dia mesti greater than 0 lah, sebab kalau tak macam bukanlah depth kan. Okay. Now let's look at the probability density function. Okay, so kalau you are looking on the discrete random variable, kita panggil dia the probability distribution function. Okay, so kalau you have a continuous random variable, kita panggil dia probability density function. Okay, but usually we would indicate them as PDF jugalah. Okay, alright, so now for fx to be a legitimate PDF, it must satisfy the following properties. Okay, so the first one is that your fx, your function of fx must be greater or equal than 0 for all x. Okay, now the total area under the graph, okay, of fx, it must be equal to 1. So basically kan kita we're dealing with probabilities kan. So the total area per se, you have something like this kan. Okay, so the total area here should be equals to 1. Okay, so usually bila you integrate something or integrate fx over dx, you akan dapat the area under the graph. Okay, so the probability that x will be between two numbers a and b is equal to the area under fx between a and b. Okay, so for instance, kalau you have a function like this, okay, so kalau you cari the probability of a to b, that is equivalent to the area under the graph. So you can integrate lah from a to b to get the area or the probability from x from a to b. Okay, right, now for continuous variable x, okay, if you have x in between a to b equal a and equal b, okay, that will be equivalent to when you have x in between a and b without the equal sign. Okay, unlike discrete random variable, if per se you have px less than 3, okay, so this is apa ni, not equals to px less or equal than 3. Okay, so for x less than 3, you only take up for px equals to 0 plus px equals to 1 plus px equals to 2. Okay, now let's look at one example. Okay, verify that the functions are probability distribution function. Okay, so now you know that if you integrate your fx over the interval, okay, you're gonna get equals to 1. So kita try lah for A. Yeah, we integrate from 0 to 2, 3 over 4x, 2 minus x dx. Okay, so yang ni, this is just you know, kalau you take 3 over 4 kan, 3 over 4 is the constant. Okay, so you can take it out, 0 to 2. This one is nothing but you will expand, you're gonna get 2x minus x squared dx. Okay, alright, so here you're gonna get 3 over 4, 2x power 2 over 2 minus x power 3 over 3. Okay, so your definite integral would take from 0 to 2. Okay, so there's no plus c, yes, but this is a definite integral. Okay, so what you do is that 3 over 4 ni, you're gonna substitute 2. Okay, yang ni you're gonna get 2 power 2 lah, which is 4, minus 2 power 3 will be 8 over 3. Okay, so all this yang when you plug into should be minus with 0 lah when you plug in 0. So 0 power 2 will be 0 minus 0 power 3, that's 0. Okay, so you will get 3 over 4 times 4 over 3, so that will be equals to 1. So therefore, okay, so therefore fx equals to 3 over 4 x 2 minus x, where x in between 0 and 2 is a probability distribution function. Okay, alright, now let's look at question B. Alright, so we have fx equals to 2e power negative 2x, where x can take up value of 0 to infinity. Okay, alright, so if the integration of fx over dx at that interval equals to 1, so fx is a PDF. Okay, so we integrate from 0 to infinity. Your fx is 2e power negative 2x dx. Okay, so yang ni you boleh use the substitution method. So you're gonna get you're gonna take u equals to 2x. Okay, so nanti you akan dapat 2e negative 2x over, you differentiate negative 2x, you're gonna get negative 2. Okay, so this is 0 to infinity. Okay, so this one, okay, so we can simplify this and then rewrite this as 1 negative 1 over e power negative e power 2x lah. Okay, alright, okay, so this is from 0 to infinity. Okay, now when you plug in infinity kan, you akan dapat berapa, negative 0 lah kan. Okay, something really small, minus that would be when x equals to 0, e will be 1. Okay, minus 1, so you akan dapat 1 lah. Okay, so therefore fx equals to 2e negative 2x is a probability density function. Okay, okay, now let's look at another example. Okay, so you have a continuous random variable t with PDF given by ft. Okay, find the value of k. Okay, so you know that when you integrate ft dt, this one is the total area under the graph, you're going to get probability 1. Okay, so you substitute your function there, so you will get okay, t ni t is greater or equal than 1, so meaning that you should integrate from 1 until infinity lah. Your ft is k, I'll just rewrite this as t power negative 4. Oh, not dt lah, dx lah kan. Okay, sebab it's a function, no, dt lah. Okay, apa aku cakap ni kan, sorry ni dt lah. Okay, okay, alright, so this one dt equals to 1. Alright, so when you integrate this, okay, you will have k ni is just a constant, so you can take it out. Okay, so that be t power negative 4 plus 1, that be t negative 3 over negative 3. Okay, so you would integrate from 1 to infinity. This one should be equals to 1. Okay, so when you plug in t as infinity, or maybe you can just rewrite this as negative k over 3 lah. So t power negative 3 ni I'll just rewrite as 1 over t power 3. Okay, 1 to infinity. Okay, so when you plug in infinity, so which means something a large number, so a large number power 3 that will be bigger, 1 over something bigger will be very small, so it will be close to 1. Okay, so you're gonna get negative k over 3, 0 minus when you plug in 1, so you're gonna get 1. Okay, equals to 1. So therefore your k will be berapa? 3 lah kan. Okay, so because negative negative positive, so you're gonna get k equals to 3. Okay, so now next question is that we need to find the property of t in between 2.5 and 3.5. Okay, so you to get the area or the property under the function, okay, at value of t 2.5 to 3.5, so you integrate 2.5 to 3.5 of your ft, that is tadi k berapa? 3 3 t power negative 4 dt. Okay, so what do you get is you integrate this, you akan dapat 3 t power negative 3 over negative 3, so this one can cancel out. Okay, you integrate 2.5 to 3.5. Okay, alright, so here, okay, so here you plug in 3.5, you're going to put 3.5 power negative 3 minus 2.5 power negative 3. Okay, so you will get berapa? 0.0778 lah, something like that. Yeah. Okay, alright. Now what about if you have t p of t less or equal than 5. Okay, so yang ni sekejap, yang ni jawapan soalannya, oh okay, ada equal sign, so whatever it is, ada equal sign ke tak ada kan, the answer should be the same lah. You still integrate 2.5 to 3.5. okay, because it's a continuous random variable. Alright, now if you're looking for t less or equal than 5 kan, your t ni must be greater or equal than 1, so you now integrate from 1 until less than 5. Okay, so put in 5, so you akan dapat 3 t power negative 4 dt. Okay, so again you're gonna get negative t power negative 3 lah bila you integrate this. Okay, so this is from 1 to 5. Okay, so here you're gonna get sekejap, sorry, yang ni ada negative sebenarnya, negative. Okay, okay, betul lah. Tolak, yang ni ada negatif juga. Okay, so then you will get okay, continue yang bawah ni. So you will get, so nanti you substitute 5 and 1, you akan dapat 0.992. That's what I've calculated. Okay, alright, now I think yang nombor 2 ni, nombor 3 Roman ni, I think you boleh buat sendiri lah. Okay, so now 4 Roman. Okay, so you would like to have property of t equals to 4. Okay, so now usually, so the answer would be 0 lah, because how can you get the property of t equals to 4? You nak integrate daripada mana ke mana kan, because the probability, you will have a value or the probability of t equals of t when you have the area, or ataupun if you have the area. So now you cannot integrate lah, because there's no interval, so therefore when there's no interval you cannot integrate, you don't get the area. So when you don't have the area, your probability will be 0. Okay, so for this example, now we're dealing with a piecewise function instead of a single function. Okay, but it's the same, you would have to use the same concept. Okay, so you need to find the value of t. Okay, so what you do is that for all interval kan, so you have 0 to 3 lah, but 0 to 2 you have a different function lah. Okay, so kalau you integrate from 0 to 2 of dx plus from 2 to 3 of 2t dx, you're gonna get equals to 1. Okay, so what is the value? So this one, you integrate, you're gonna get dx squared over 2. That's from 0 to 2 plus t is just a constant. Okay, so you integrate over dx, you will get 2tx from 2 to 3, and this the total of the total will be equals to 1. Okay, so nanti you calculate, you're gonna get so So this one nanti you akan dapat 2 power 2, that is 4. 4 over 2, you're gonna get 2t. Okay, yang ni 0, bila you plug in 0, you akan dapat 0 lah, minus 0, plus yang this one would be 3 times 2, 6t. Okay, minus 2 times 2, 4t. Okay, equals to 1. So you simplify this, you're going to get 4t equals to 1. So t will be 1 over 4. Okay, so therefore you will have this one as 1 over 4x, and this one as 2 times 1 over 4, that's half. Okay, right, now sketch the graph of fx. Okay, so that's quite straightforward. You would have the x there. Okay, and your y-axis would be the fx, or the probability function lah. Okay, okay, so from 0 to 2, you would have 1 over 4x, so that be just a linear je lah, macam tu kan. Okay, and then from 2 to 3, you have y or fx equals to half, so that's just a straight line there. Okay, or not. Okay, alright, so that is your graph of fx. Okay, now find the property of x 0 to 2. Okay, so as you know that you can use the integration, kan, you boleh integrate 0 to 2 of the function interval 0 to 2. You should take t lah, 1 over 4x dx. Okay, or you can, because you have sketched the graph, you know that the property is equal to the area under the graph, kan. So yang ni, this would be the area of a triangle je lah. Okay, so half of 2 times yang ni would be 0.5 lah. Okay, alright, so that's going to be your area or your probability from x from 0 to 2. Okay, so the same thing kalau you cari 2 to 3, kan, that's quite straightforward. Okay, but now what about if you want to find the probability sorry, what's that? Property of x in between 1 until 2.8. Okay, so here you need to split them up because it's a piecewise function. Daripada 1 to 2, you're gonna have the first function 1 over 4x dx. The second part is you integrate from 2 to 2.8 using the other function, which is half dx. Okay, so nanti you akan dapat 1 over 4 x plus 2 per 2. Okay, this is from 2 to 1 plus half x lah. This is from 2 to 2.8. Okay, alright. Okay, so this one nanti you calculate lah. I pun tak lambat nak tunjuk lah. Okay, so you will get, I think 0.775. Okay, right, so now the question C, 4 Roman. So you would like to find the property of modulus x minus 2 less than 1. Okay, so here you are actually looking for px minus 2, that is in between -1 and 1. Okay, ingat you belajar inequality kan, alright. So but just now you ada property of x saja kan, or the function of x. Okay, you tak ada function of x minus 2. So what you can do is that, okay, you can plus 2 on both sides. Okay, so you akan dapat semua lah, plus 2 plus 2, so you're gonna get x minus 2 plus 2, so you akan dapat x saja. Okay, this one would be 1. On your right side, you akan dapat 3. Okay, ni x. Okay, so then only you integrate them lah, from 1 to 3. Oh, okay, so you have to split them up. Okay, so from 1 to 2, you have 1 over 4x dx. From 2 to 3, you're gonna have half dx. Okay, so nanti you carilah jawapan dia. Okay, that should be okay. Okay. Okay, so now last example. Okay, so you have the continuous random variable x represent the amount of time measured in an hour when visibility with torchlight is a permissible level for climbing between 2 a.m. to 7 a.m. at the summit of Mount Kinabalu. So the probability density function is given by fx there. Find the value of k. Okay, so x is your number of hours, kan, that you can climb Mount Kinabalu from 2 to 7. Okay, so find the value of k. So you know that x ni from 0 to 5, if you integrate 0 to 5 of kx squared over dx, you akan dapat sama 1. Okay, so that one you integrate, you akan dapat 3x cubed over 3. 0 to 5 equals to 1. Ini you substitute 5, you're going to get K, ini 5 power 3 over 3 minus 0 lah, equals to 1. Okay, so you continue here. So nanti you akan dapat K equals to 1 over 5 power 3, which is 125. Okay, so sorry, 3, ya Allah. Okay, 3 dah. Okay, alright, now find the probability that on a particular day there are 2 to 3 hours of visibility with torchlight above permissible level for climbing between 2 to 7. Okay, so to get B ni, you integrate apa? Z 2 to 7 ke 2 to 3? Okay, so your X is the number of hours that you can climb, bukannya pukul berapa. Okay, so your X will be from 2 to 3. Okay, your K just now is 3 over 125, so you will get 3 over 125 of X kuasa 2 dx. Okay, so this one is quite straightforward. You integrate them and plug in values of 3 minus when the values are 2, so you akan dapat 0.152. Yeah, alright. Okay, now before we end the lecture, okay, before we end the topic, okay, I would like to explain a little bit of concept of percentile and median. Okay, so when we say that an individual's test score was at 85th percentile of the population, we mean that 85% of all population scores were below that score and 15% were above. Okay, so similarly, when you have 40th percentile, is the score that exceeds 40% of the score and is exceeded by 60% of the score. Okay, so maksudnya here, okay, you would have the probability of okay, so another example is that probably you're studying per se data ni, X ni. Okay, this is the X is months, X probably months, X is like how many months does so contoh X ni per se is how many months you in a relationship with a guy, kan? Okay, contoh lah, okay? So X can be 0 until 20 months lah, okay? So kalau if you look at the histogram kan, so on average, it would be like 10 months saja. Average 10 months, lepas tu you break up kan, okay? So if I have something like this, which is I have the 20th percentile of a random variable X is 7, so which means you can also rewrite this statement as probability of X less than 7 would be 0.2. Okay, ataupun you can put the equal sign ke tak ke, it's up to you then lah. Okay, so now what about median? Okay, so katalah okay, what about median? So median is the equals to the 50th percentile, percentile. Okay, alright, so let's look at one example. Okay, now if X be the age of woman at marriage, okay, so given that PX less than 19 is equals to 0.19, so which means that 19% women, okay, married at age 19 or lesser. Okay, alright, now you have a variable y be the age of men at marriage, and given that py less than 19 is 0.29, which means what? Okay, 29%, okay, of men married at age 19 or lesser. Okay, so now what can you conclude based on these two information? So from here, okay, kalau I would conclude that what dia lelaki kahwin lagi awal lagi, I mean at the same age, lelaki kahwin lebih banyak lelaki kahwin pada umur 19 atau kurang. Okay, so maksudnya apa? Lelaki lagi gatal lah macam tu. Okay, so now how does percentile related to cumulative distribution function? Okay, so as you know that if you have the CDF kan, fx kan, this is equal to property of x less than or equal than x kan. And this is what you learn with Dr. Siti, which is it is the same definition for cumulative distribution function for continuous random variable. So as you know that, you nampak kan yang this one kan and this one, right? So they're related lah. That's why I'm discussing a little bit on the percentile before we move to the cumulative distribution function on our next lecture. So that's all for today. So remember on the we would expect you to, I would expect you to be able to differentiate between continuous and discrete random variable, and then you have to know the properties of cumulative density function for continuous random variable, and also the concept of percentile and the cumulative distribution function. Okay, that's all for tonight. So happy PKP, not happy PKP. Tak seronok pun sebenarnya, tak boleh keluar. Okay, take care everyone. Assalamualaikum and good night.